Good afternoon, and thank you for joining us after your lunch break. Such a pleasure to be here with such innovative minds, and I've enjoyed visiting with so many of you over the last 2 days. I've heard some really interesting concepts and thoughts, and I've also seen some amazing products. It's the dreamers who take action. And speaking of the dreamers who take action, I have to start with a look back in time to some of the original. These are a few of my favorite pictures. Of course, there's many here, many that aren't included here, and some that we even saw yesterday briefing. And of course, in terms of superpowers, way back, they were thinking of superpowers even at that time. So as we fast forward to more recent times, we're seeing some really interesting things taking place with augmented reality. From optimizing what is around us, to improving what is within us, from accelerating our path to knowledge, and even enhancing our journey to the next adventure. We're seeing what the visionaries had in mind, or at least the early stages of it. And then there's golf. Do we have any golf fans in the crowd? It's fun to see what's taking place in that environment as well. The question is, how does this apply within the manufacturing environment at Lockheed Martin? Thanks to the pioneers from decades ago, as well as the persistence and the sheer determination from those of you today, augmented reality is going to be one of the most influential technological feats of our time. I'm Shelley Peterson. I work for Lockheed Martin Space Division out of Denver, Colorado. I'd like to share with you how several of the top use cases that you've seen this week are being utilized and how they influence what we do in space manufacturing and why it's important to us. We hear that many enterprise divisions are looking into this technology. I can share some of the insight on why. So before we go too far, let's look at Lockheed as a whole. Lockheed has 4 business areas. Our products and solutions span not only the defense industry, but also civil and commercial. In addition to pursuing AR and MR solutions for space systems, I support a corporate human augmentation board. And at the corporate level, we're looking at AR solutions across all of the business areas and how to strategically deploy the technology and the roadmaps to get there. So today I would like to focus more on the space side, a few characteristics of that environment. What you see here are large numbers in terms of spacecraft. 800 satellites in 50 years, that's a large number in terms of space. But when you look at other industries, manufacturing industries, these numbers are very small. I had a colleague at the corporate level ask the question, how much can we really save when we're producing very small numbers of spacecraft? 1 or maybe 10 of products. We looked at those use cases from many angles. We found that not only did we have the potential to save just as much, but in some cases, with those small numbers, we could save even more. There's a number of factors which feed into this, and I'd like to discuss 3 of the primary. So the first, we have experts who support many programs. These experts have teams across the US and in some cases across the globe. And 2, the spacecraft must be perfect. So after a spacecraft is launched, the options to fix it are limited. So it's important to perform the manufacturing process correctly the first time. There's a lot at stake for the success of the program if it's not manufactured correctly the first time. And in the case of errors are very expensive. You have review boards to make sure that the product is corrected and that there's 100% mission success that's expected. So the downtime imposed by errors is also incredibly costly. And when you think of the risk to the schedule, we have to hit specific launch windows. If an error causes a delay in the program, that launch window, we run a risk of missing it. So if we don't hit the launch window, it can be months or even years before we have another opportunity. So you can see how critical it is to perform the steps correctly the first time. And then 3. Notice the gear that our technicians wear. Can you imagine wearing this for 8 hours a day or 12 hours a day, every day? Okay, this is something that they have to do for our 10K clean rooms. And to get into a 10K clean room, they start off by going through a lower level clean room. So they walk into the building, they put on a smock and boots, they walk across a sticky pad, and then they go into the clean room environment, walk across that clean room environment into the higher level dressing room for the higher level clean room environment. And look at what this involves. They have to put on a clean room suit and boots. They have head covers, they have face covers, they have gloves and glove tape. They have a safety glass tether. Anything that is loose has to be tethered because we can't risk anything being dropped or falling onto the spacecraft. If they're working with tools, they have a tool tether. It's a strap that they attach the tool to so it can't be dropped into the spacecraft. And then the electrostatic discharge strap. So if you had an older brother or sister who liked to scoot across the floor and zap you when you were little, that's what we're preventing here with the ESD straps. They go through an air shower, they walk across sticky mats, and then they're in the environment. So if a technician needs support from one of those experts who is supporting multiple programs across the United States, that expert often wants to be in the room because they want to make sure that the task is performed correctly the first time. That expert has to go through this process to support, in some cases, hours. In other cases, it might be just a few minutes of conversation. Then they go through the reverse process to get back out of the room to go back to the work that they were performing before they were called. So you can see where this is going, right? We need better tools for the experts to support the teams. A review of the scenario, we have small numbers. Our experts are supporting many groups across the country and even the world. We have high-value hardware. Quality is critical. And then this need to dress in the clean room gear is very time-consuming. So how can AR and wearables benefit? Of course, there's remote assistance. We've seen that scenario many times. It keeps production rolling. It aligns the skill with the task. We have reduced traffic within the production environment, which is also a significant positive for these environments. We also appreciate the return on investment for remote assistant technology. When you look at many of the AR use cases, they require quite a bit of effort to get to the point where you can use the technology. With remote assistance, once you have that capability available within your enterprise environment, it can be used across the corporation. There's no need to modify anything in order to benefit from the technology. So the return on investment is nice. There's also an interest, if we go back in time, Mr. Bell, of course, helped us with the Hear Me capability, but as humans, we wanted more than that, so we wanted the capability to see me. Engineers and technicians aren't necessarily so enamored with the See Me technology, because this is what it would look like. So we hear a lot about See What I See, the remote assist technology. And I think that we've possibly named it incorrectly. Instead of see what I see it more of a know what I know. The technician is wanting the expert to see what they see, but that's not where the value is. The value is with the expert being able to offer that insight so that for at least that topic, that element, the technician understands on the level of the expert. We do it quickly, much more quickly than having to go through the clean room gear process. So I think that the remote assist technology belongs here, and that knowledge transfer is powerful. So this one gets our superpower stamp. And then another use case that we see quite often is work instruction. And if you haven't demoed a work instruction scenario, I encourage you to go over to the expo hall and try one of the work instruction demos that you can find there. It's amazing what you can do with this technology. It won't be limited just to enterprise manufacturing. We'll see it in our everyday lives for things like IKEA, or for my nephew for things like snap circuits or Legos. It'll be used widely. But in our work environment, enhanced work instruction has the potential for great power. When you think about the process, we develop in 3D. In traditional methods, we convert that 3D model back down into text and picture for the work instruction to build the 3D object. And then we maintain that real-life object back in text and picture instruction. With augmented reality, we can stay in 3D across the entire cycle, which is powerful. We can also use that to our advantage in maintaining data along that path, what we refer to as the digital tapestry, where we can make use of data through every step. Of course, today there are many more steps to implementation for work instruction than for something like remote assist, but it's come a long way in the last couple of years, and we expect it to continue down that accelerated path over the next several years. We believe that this technology can be a game changer. And it's not just because of the time and the error mitigation that we see quantified in so many studies. When we look at the decision process, something like the OODA loop, we find some interesting things. The OODA loop is to observe, orient, decide, and act. And this was developed by the Air Force a long time ago. It's for more of a strategic thought process in wartime. But we've also seen manufacturing organizations, automotive industry, even legal, use this OODA loop process for decision logic. When we look at work instruction time and what happens with each one of these phases when a technician is interpreting work instruction, if we look at the traditional methods, they spend a lot of time observing and orienting and deciding, and then the time for the action. They receive these blueprint documents that are very complex, and again, in space, we may be creating that system for the first time, or it may have been a period of time before, since we have built it in the past. There's a lot of focus put on that observation and orientation so that they get it right the first time. When we take a look at AR and MR technology, where we can overlay the instruction onto the actual hardware, this is what we see relatively. We see the time shrink significantly for observation and orientation in that decision process. And for the action, we even see some benefits in that area as well. Augmented reality and wearables provide significant time savings. We could create a similar chart for the cognitive load, where observation and orientation are much more streamlined in terms of cognitive load. So this one gets our superpower stamp as well. Now, these are just two of the areas where we see the superpower stamp becoming more real. And then I have groups within Lockheed and outside of Lockheed ask quite often, what should we pilot? How do we pilot? We want to get involved. Where do we start? Anytime I hear pilot, this graphic is what pops into my head. Not because he's flying through the air, but because he probably didn't think when he punched the gas that this was going to happen. With pilots, we learn those things that we didn't expect to happen, or that we didn't think about. It's a great time to explore and to learn some of the basics. For example, if you see demos here and in the expo hall, but your use case is based outdoors, You really want to take that technology and take it into your environment and see how it works within your environment. That's one example. It can go from basic to very complex. But I also like to emphasize that for the technology to become real, the pilot phase must transition into a value assessment where you're quantifying how that technology matches your specific use case. What are the optimizations? What are the risks? What can you quantify? What can you learn about what else needs to be done for the end-to-end cycle for your environment? All of that feeds into an ROI analysis so that you can make better decisions on what to invest and to what degree to deploy the technology within your environment. And have any of you heard of the iron triangle, the better, faster, cheaper? Okay. The thought is that you can really only accomplish 2 of the 3. What we're seeing is that with the right strategy and the appropriate roadmap, with this technology, you can accomplish all 3. It's possible, but you have to be very cautious with how much time you spend in that pilot phase and how much you spend on the early stage exploration and how you strategize the implementation that goes along with it. So I'd like to encourage, as an ending slide, to follow your curiosities, but to do so strategically and to think through the longer term roadmaps and where you want to end up. I think that we'll see many more of the dreamers' dreams turned into reality through these actions.
Thank you again, Shelley,
you.
for that insight.